In this session, we are going to look at the sample scripts provided with the KM. We will look at what common use cases those demonstrate, about the challenges we encounter when we come to actually write a script. How do we read the data from a certain source and then format it to the way that a KM can consume it? And finally, see some examples on how we can really make the data valuable in the sense that there is more there to read numbers. For example, what do we do when we actually want to set up value, which is a delta between two different collection cycles? How do we come to calculate an average or possibly scale the numbers so it rounds up to a certain level? We'll see all of that right away. Here you can see an installation of the KM on a Linux system I have. Right now I'm somewhere in the Patrol 3 folder, all that known. And I actually go drill down into a folder under the TRO conf samples files. Looking into this folder, I can see about roughly 10 different scripts, and each one of them is doing different things. When looking at one of the scripts, for example, let's say netstat monitor, then we can see that the script in general starts with a description, the purpose of the script, what it's going to demonstrate, and several items that the user should notice. In the case of this script, the network monitoring one, we not only show how to collect data from a utility called netstat, but we also show how to set up values with averages, or actually with delta. And how do we scale this to provide the data that doesn't have too many, let's say, digit after the point, decimal point. We will also show that we can convert deltas into rate when we can actually divide by the polling cycle. Let us first run the script and see what it does. So I'm going to run the script once. Let's see the output. And as we can see, maybe we should do it again. We can see that the script basically highlighted 3 lines, and that they are manifested in this way. Notice I get a standard in error, and the reason I get this is due to a difference that I have between the different operating systems, even within Linux. And this is also something very important. The script utilizes a command called netstat --interfaces. And it basically reads this entire line and picks up those different numbers. It then compares the numbers received here with the ones implemented in the previous triggering of the script, and then subtract one from the next and has the delta, which is the amount of received packets on each and every one of the interfaces. And the same goes for, of course, transmitted, or when we look at errors, dropped, etc. Now, looking at the output of a different host, I can actually pick up this one, and if I run the command netstat --interfaces, you can see that this one has another column. In this case, it says MET. And as a result, the script would fail on this host here because it doesn't have this one. So as said in the previous session, when you create scripts, you should make sure that those can run on the targeted hosts. Now, in this example, what you can see is several techniques. The first one is actually about removing the headers, which is this one and that one. And then something else. It has to do with the fact that we get the data in a table-like mode, but we actually want it as a report, like it's shown over here. So let's observe how the script is actually doing this. As you can see, the first thing that the script is doing is just trying to figure out if this met flag exists or not. And sometimes it works, sometimes it doesn't. But in essence, it tries to figure out the type of system. So you can see that when you realize that you're going to run the script on a collection of systems and they slightly differ, you probably want to set up flags in the script to figure out if you run on one type or another. Then we actually use functions in here, and I'll explain why in a bit. But as we go all the way down, then we can see that the script actually implements execute this section of the code, and eventually calls the function process.line. So start the code over here, start iterating over the output of this command, and call the function. What is exactly happening here? So first you can see that we issued the entire output of the command, and we actually do remove the titles. We then actually call something very important. We reduce the number of space characters between columns to just one. And finally, we replace that one with a comma. This is very important because this causes the for loop to print or to issue each line with its entire set of arguments. If we don't replace the space to a comma, then actually the for loop will issue a line for every word in the output, and this is not desired. Once we do this, then of course the line doesn't have any spaces in it. It actually has commas, but that's okay. We take this into account. And the first thing we see is that when we run this, is that we have the interface. So we spoke about the fact that we actually remove this and we remove that one. So we now get only the 3 lines. The first one is actually the interface name. I would like to instantiate according to it because I'm going to set parameters according to these values. And I'm going to set the parameters of an instance named ETH2 or ETH3, etc. So the first thing I'm doing, I'm taking the interface name and I'm taking it according to comma, the first field. And then I actually take clean line and I revert the comma back to space. Now, and here is a very tricky part. I check whether there is a previous data collection of the same. Notice how I use the $0 variable in here to create previous files with data that actually serve as a temporary files where the prefix is actually the prefix of the script. And if such exists, I know I can actually calculate delta values. If I don't, then I just print 0 numbers one time and I dump the entire line into what will be the previous collection for the next polling cycle. So let's assume we are on the second collection cycle and we already have previous data collected in here. In that case, what we're basically doing, and that's the tricky part, we're calling the function and we're adding to it the line that was cleaned from our current numbers. Let's observe the data again. It means this line. And then the previous data that was collected. As you can see, the output of cut of the file. And it's all being sent to the function. The function in turn is this one, and it just gets a very long list of arguments. And then you can see that if I get the data of the current line and then concatenated to it the previous one, then obviously subtracting the previous value from this one would yield the delta. So probably we're talking about, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So roughly 14, 13, 14, or 15 will be the value from the previous one. Based on that, I can now see that that's exactly what I do. I do the receive OK will actually have echo third argument minus 14. And notice how I use pipe to the calculator, because I actually wanted to get, I want the calculator to actually calculate the subtraction result. So this is what I get in here. And then I actually want to calculate the rate as well. So the rate is the number of bytes that were received per second. And in order to do that, I need to know how many seconds passed since the last polling cycle. So what I do first, I always actually take it, and it's illustrated in here. When I know there is a file, I actually take the date in epoch, which stands for the number of seconds in January 1st, 1970. And then I do it again. And then the difference between seconds is the polling cycle. And you can see how I do prev timestamp, which means the one that comes from here. And then I do actually now, and I subtract prev, and I get, again, the calculator to tell me the polling cycle. So by now I can use this same variable. It's obviously global because it's a script. I actually divide by it, and then I get the value normalized to the number of bytes per second. In other words, rate. But as I said earlier, problem with this, when we divide, we can actually get very long number, like a huge floating point type of a number. So I actually tell the calculator that I only want 2 digits behind the decimal point, and this is the way to do this. So this is how I basically calculate all the different values, and eventually I just echo to the output in a monitor type called interface. E1 will be the, of course, instance name. That's E1, and that will be E1 again, and then the following line, and that one. And then, of course, the values I calculated, for example, rec OK will be rec OK equals here, and receive OK rate will be over here. And notice how I decide that the parameter names will actually bear the same name as the variables, which is, I decided to do it in here, but of course you can change this however you deem necessary. Finally, after we actually scanned across all the output lines of the command, which is, in this case, for example, that's 3 for 3 interfaces, then the final line is to just dump the timestamp into the previous file, and we need this, so by the time we do the scanning again, we will be able to tell how long it has been since the previous one. Now, this is about the network activity sample. Next interesting script is actually one where we do a trace route. It's a very nice kind of a script, if I may say so. This script actually uses the output of Traceroute, and Traceroute is a kind of a utility that basically show the devices through which a routing sequence would go between host A to host B, and it actually tells whether the hosts in between received packages and the time it took. So for example, if I do trace route from this host here to let's say VL, TLV, NGP, BMC, then you can actually see that that the request is going through several devices, 1, 2, 3, 4, and it's not done yet. For each and every one of those, it tried to figure out how long it takes for the message to be processed by that device. So from my own host, being this VM, I sent packages to this device, and it took it 3 packages, and it took the packages to be processed 3 periods, and then I did for all the others as well. And as you can see, this script can actually run for quite a while, and the devices may actually be faster to respond or slower. And finally, we can see that it identified 9 different devices until it finally achieved the destination. When I run my script in this case, I want it to qualify for the format. So the script actually accepts a value, and the value would be the target host. So in this case, I want also to target that same host. For the sake of time, let's just copy this over. I triggered the script once, and then I triggered again. I forgot to actually add this. So finally, the script ran, and I would like you to notice several things. First, I created this script actually introduces a monitor type called routing host. I call it this way because I want to instantiate a given host in TrueSight, and I want to show the response time it took to handle a message. First message, second message, third, and finally the average across all 3. And I also wanted those to show up on TrueSight in the order that they were identified. But the thing is, either TrueSight or Patrol, we sort the names alphabetically. So I also made the script place index numbers of the hops across the network, and I made sure leading zeros are there as well to handle this. So finally, this is the output, and of course, TrueSight can consume this as it has a monitoring type equals a name, and then a sequence with a comma separated name and numeric value, etc. Let's look at the script. So in this case, it's very simple actually. It's basically taking on the traceroute command, giving it the command line argument that was provided to the script, so the target host. And then I actually switch the space to, in this case, plus again, so the for loop actually yields entire lines. And then I actually create a clean line by reverting the plus to spaces again. Finally, I call a function where I can handle the lines words as arguments. So process host is actually in here. And actually, I can tell whether each line succeeded or not according to the number of arguments. In the case that I have exactly 9 arguments, that would be where I have all the information. So when observing this, that would be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Sometimes we have more or less depending on errors. Some devices would not respond. And in here it's commented, but the script can highlight this, for example, when there is no data. Anyways, notice how we calculate the average that we would like to place at the end, the runtime message average, the response time is that we scale as earlier, but we actually take the values of 4, 6, and 8 and divide by 3. That's a standard for averaging. And of course, we pipe into BC. The outcome is, of course, in this value. Now notice how we handle the leading zero. So we use a very neat utility called printf, and we actually tell it to take the first argument that was given to the function, being the index number. So when you look about it, it's this one. Every time an entire line is sent to the function, this is the first argument, or this one, or that one. But we actually tell it like the printf from C that we would like to have one leading zero, and as a result, the hop number, if you will, has a leading zero, so it will be well nicely aligned. And finally, I actually call echo with I name the monitor type. I make sure that the hop number with the leading zero is provided with enclosed, and then the second argument is, of course, the host name. I have no desire for the IP itself in this case, in here, but I do take the values, and I decide to call parameters. First message will have the 4th, second message the 6th, third, 8th, and finally the average will get the average that was calculated in here. That's it. This is the Traceroute sample script, and feel free to use it. Here on the text above, you can see how to use it within a policy. The fact that it monitors the network timing between two devices, but actually knowing that the KM can run a script remotely, and this is a bit confusing. Patrol agent can actually be running on host A, and it can shoot a remote script request on host B, and host B will actually measure the network to host C. So this script doesn't really have to measure the network timing between where the agent resides and then some target. It actually can monitor the performance, the network performance and responsiveness between any two network devices out there. So it's very cool. Also, something interesting is if your system suffers from performance, and the performance is due to some unstable routing or the fact that you go through ad hoc networks, then the outcome will be that your trace route will keep on changing. And the result of that would be that on TrueSight presentation server, you will see more and more new devices that are sorting out the route. This usually means that there is no persistent route between the two hosts. So if it may actually suggest a lower or a longer time to response. You may think about it as a general network issue or just the fact that you are connected through dynamically assigned connections, maybe ad hoc networks. That's it. Thank you. As for the rest of the scripts, due to the length of this video, we will carry on with the following session where we would be able to discuss other ones like the Informix monitor or the cron. There are other subjects, and we will discuss those in the following session.